Hello. So today is part 2 of dilations. So we're going to do two different types of dilations. One of them is like this, still on the coordinate plane, but now the center of dilation is no longer 0, 0. So yesterday we learned that when the center of dilation is 0, 0, you can simply multiply the ordered pairs by the scale factor. When you have a center of dilation that is not 0, 0, you cannot just multiply the ordered pairs by the scale factor. So I'll show you what to do now. So we're going to do that. And we're also going to learn how to do dilations completely off the coordinate plane. So I'm going to do a few of these examples, and then you're just going to finish whatever we don't do on these two papers. Okay, so let me zoom in a little bit here. The first thing that you want to do is plot the center of dilation. So it's going to be 0, 3, which is right here. D. Okay, so it's hard to write out these steps in words. It's better to just for me to show you. So you might need to watch this video a couple times. So basically, if this one, the scale factor is 1/4. Now, if you remember yesterday in the lesson, I showed you how your image and your pre-image points, if you line them up, they always line up to the center of dilation. So we're kind of going to go off that to help us figure out where these points are supposed to go. The scale factor is 1/4. So basically what that means is each of these points, the new point is going to be 1/4 of the distance from the center of dilation to the point. When it's a horizontal or a vertical like this, it's pretty easy. So basically what you're going to do for each point, here's my center of dilation. I'm going to start at the center of dilation. I'm going to count how far each point is from the center of dilation. So A is 1, 2, 3, 4 units up. So the path from D to A is 4. The path from D to A prime needs to be 1/4 of that. So 1/4 of 4 is 1. So instead of going up 4 to A prime, to A, I'm only going to go up 1 to A prime. Let's look at B. B is 1, 2, 3, 4 units to the right of D. So the path from D to B is 4. Again, we need 1/4 of that, which is 1 again. So just to the right 1 is going to be your B prime. Okay, and then our C is on a diagonal. So rather than counting diagonals, because sometimes it can get messy if it's not right in the middle, so I'm not going to show you that. I'm just going to count down into the right or right and then down. So from D to C, I'm going to go down 1, 2, 3, 4, and then right 1, 2, 3, 4. So I'm going to cut those two paths, 4 and 4, by 1/4. So I'm going to go, instead of down 4, right 4, I'm just going to go down 1, right 1. So that's going to be my C prime. So we end up with a very tiny triangle, but you'll see that it's still the same exact shape as the original. So it's just this little triangle right here. You can see that your image and pre-image side lengths are parallel, just like I said they would be. This one's parallel to this one's parallel to this one. If you were to line up your image and your pre-image points, they line up to the center of dilation. So there's one example. I'll do a couple more. Number 2, center of dilation is 0, -1. So there's my center of dilation, D. This one's a scale factor of 2, which is going to be an enlargement. So if you look at A is 1 unit up from D. So now I'm going to go back to D. Instead of going 1 unit up, I'm going to double that because the scale factor is 2, and I'm going to go 2 units up. So A prime is here. Notice that A prime is not 2 units up from A, it's 2 units up from D. So from D to A is 1 unit, from D to A prime is 2. You don't want to go 2 from A. That's a pretty common error for kids, is they go from the pre-image point instead of from the center. You always want to keep going back to the center of dilation. So B is up 1, right 1 from D. So we're going to double those paths of up 1, right 1, and we're going to go up 2, right 2. Another way to do it is once you get one of your points in place, like once I got A prime in place, I know that AB is 1 unit, and so A prime, B prime has to be 2 units. So you could just like make it 2 units over from A prime. That's another way you could kind of do it. C is down 1, right 1 from D. So C prime is going to be down 2, right 2. Or again, I could have noticed that from B to C is 2 units. So that tells me from B prime to C prime has to be 4 units. Okay, then just connect. Okay, so there is number 2. Let's do another one. Let's do number 3. Or actually, I'm going to do another fraction one because I feel like those are a little bit harder. So I'm going to do number 6. Center of dilation is -4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, scale factor is 1/3. So again, I'm going to count my distances. I'm going to cut that distance by 3. By 1, cut it in a third. Divide by 3, multiply by a third, whatever. Okay, so from D to C, it's 1, 2, 3 units. So now from D to C prime, I need to take 3 and multiply it by a third, or take a third of it, which is 1. So it's going to be right here, C prime. B is 1, 2, 3 units to the right. So instead of 3, it's going to be 1/3 of that, which is just 1. So that's going to be B. A is down 3, right 3. 1/3 of 3 and 3 is 1 and 1. So down 1, right 1. I guess that one wasn't too difficult, huh? That one. And I guess let's do one more. I'll do number 4. So that's 4 examples. I think that's pretty good. Okay, center of dilation is 3, 3, which is right here. This time scale factor is 4. So C is 1 left of D. So now C prime, we have to multiply that by 4, is going to be 4. 1, 2, 3, 4. Remember, it's not 4 over from C, it's 4 over from D. A is 1 unit down from D, so A prime is going to be 1, 2, 3, 4 units down from D. B is right 1, down 1, so B prime is going to be right 4, down 4. And that's it. So there's that. So that's how you do it on the coordinate plane, but just the center of dilation that's not 0, 0. Next, I'm going to show you, these I don't have too many examples, so I'm just going to do number 1. So for this one, zoom out a little bit, we are given a figure off the coordinate plane and asked to dilate it. So this notation means D for dilate. E is the center of, not rotation, the center of dilation, and 2.5 is the scale factor. So this is the scale factor. And this just tells you what you're dilating. So this. So we're going to make this 2.5 times bigger from E. So it's going to be like over here. So what we're going to do here, I'm going to switch to my pencil so we can, just in case I make a mistake. Remember how I said that the points all touch at the center of dilation. That's pretty much what we're going to use here. So the process for this is you're going to start off by connecting, pick one point to start with, connect it to point E. So see B right here, I'm going to connect B to E. And actually not just connect it, but extend this line beyond B, like way out here. And so kind of like jumping off of what we just did with counting the units and then multiplying it by the scale factor, we're going to measure how far E is from B. We're going to jot down that measurement and we're going to multiply that by 2.5. And then we're going to measure where B prime is going to be. So watch, I'll show you. So I'm going to do in centimeters. So let's see. Looks like it's about 3.7 centimeters from E to B. So off to the side, if I do 3.7 times 2.5, I'm going to grab my calculator. 2.5 times 3.7 is 9.25. So that means that B prime is going to be 9.25 centimeters from E. So I already drew the line. So now I just have to measure from E. The important part is that you always go from E, not from B. So 9.25 is going to be like here. So there's my B prime. And then you just do the same thing for all of them. So again, carefully connect E to C. Extend it. Then you're going to measure how far is E to C. I'd say that's about 4.8 from E to C. So 4.8 times 2.5. And that's going to tell us where C prime is, which is 12. So back to E. 12 is over here. So that's where my C prime is. And you just do that for all of them. Let's do A. It's important to try to do your best to connect it right in the middle of E and then right through the vertex. I kind of messed up on mine, but it's okay. Okay. Let's see, E to A is, looks like just about 3 centimeters. So then 3 times 2.5 is going to be 7.5. So go back to E, and we want 7.5 on this line, which is here. Make sure you're labeling with the prime symbols too. That's important. And now E to D. And then just measure E to D. I'd say about 4.3. So 4.3 centimeters times 2.5 centimeters is 10.75. And that's for D prime. So go back to E, measure 10.75. So 10.5, 10.7, like here. Okay, once you get all of your new points, your image points, now connect those to make a polygon. Okay, and then I like to lightly shade in the one that I made just so it like pops out with all these lines. Okay, so there's that. So I'm just going to do one example because there's only a couple on here. So you guys are going to do 2 and 3. And then onto the back, it has you find the scale factor. So think about, it also has you find the center of dilation. So think about how, notice how all of these points intersect at the center of dilation. So that's how you can find the center of dilation on these, is if you just connect A to A prime, B to B prime, C to C prime, E to E prime, D to D prime. They'll all intersect at one point, and that's your center of dilation. And then you can kind of like find the scale factor going backwards. So I think you guys should be able to figure it out. It's maybe a little tricky, but just think about it. And if anyone is interested in practicing this a little bit more, just let me know. I can put some on Classroom or send you some, because there is one like this on your test next week. All right, so that's it. Let me know if you have questions. You can come for ACT Lab today. It's at the regular time. And otherwise, have a great day, and I will see you next week.